We're at 11.1, brand new chapter. Expressing roots. All right, so just as kind of like a reminder, 3 squared is what?
8. No. 9.
It is not 3 times 2 or whatever Whit did. It is 3 times itself. We do remember this, yes? Okay. What about if I were to give you this?
-3 times -3 times -3.
Wait, how many times are you doing that?
-3 times -3.
-3 times -3, which gives you. So, do you see 3 squared and -3 squared, as long as it's in the parentheses, are the same thing? Do y'all see that? So then, this is what?
3.
Is it just that? Ah, or it can be -3, because -3 times -3 is in fact +9. Do y'all see that? So all this time you've been taught that the square root of 9 is 3. Okay, y'all get that. But it can also be -3, because again, -3 times -3 is 9. So therefore, it would be written as +-3.
That's weird. So like,
Now, if you were to write, like if I asked you what was the square root of 9 and you wrote it this way, 3 or -3, that's not wrong. You can write it either way, okay? I just don't want you to see this in your homework or on a quiz or test or the Iowa or next year and be totally confused. What does that mean? That means +3 and -3. That's all that means. Does everyone understand that? All right, then we'll move on. What is that called? Don't say check thingy. Radical sign. That is called the radical sign. Or the radical. Yeah. I still have people calling it the check thingy. Does not mean division. It's a radical sign. What is the 9?
The radicand.
Ah, very good. That's the radicand. Excellent. I'm impressed that you remember that. Okay, you need to know that that's the radicand. Now, is it detrimental if you don't remember the vocabulary? It's not detrimental. Can you pass Algebra 1 calling this the check thingy?
yes.
Yes, you can. You can pass Algebra 1 calling this the check thingy.
But not algebra 2.
Well, I mean, as long as you know what it does. You may come across a teacher or professor that, will flip their lid if you call it the check thingy. But if you understand what it does and what you're doing, it doesn't matter what you call it. I'll have students every year call it the check thingy. See? Check thingy.
Oh, okay, that makes sense.
I even
I see it
wrote
now.
not check thingy.
Okay. Positive. All right. Positive. That would be like the square root of 9 is 3. Or the square root of 16 is what? 4. Okay? Yes, I know it could be also negative 4. But that is an example of positive. Negative. Let's say I have a negative sign on the outside. That would give me negative 4. You know, kind of like you would with parentheses or absolute value. You see what I'm saying? It's kind of like I said with parentheses or absolute value. That'd be negative 3. That negative sign tells you if they want a negative root or not. And I'll explain that later. Huh? That's up to you. I'm still teaching. Okay, but I've had a lot of distractions, like toilet, pencil breaking.
Bless you. Sneezing.
All right. Wait, make sure everyone has this down. Okay, we ready? Okay, here's where we start getting crazy, so I need y'all to really pay attention. Write that down. Do you see anything in the check thingy?
No.
Does anyone see anything? Do you see any number or anything? I'm going to write nothing. And I'll draw another arrow. Means 2. Kind of like the understood 1 or the understood this, that, and the other. You know what I'm saying? Shh. So whenever you have a radical sign that has nothing in there, we're going to assume there's a 2. So whenever there's nothing in the radical sign, nothing in the check thingy, we're going to assume there's a 2. Because what that means is 9 times 9. There's 2. No, 3. Why don't y'all correct me?
Well, because I didn't know.
Okay, so whenever there's nothing there, we assume there's 2. Root of 2. So that means the number times itself 2 times, which gives you 3. So, for example, if I had 25, Emily, is there a root there? Is there anything there? What do we assume is there? 2. That means we got to find a number times itself. How many times? 2 times. What number times itself 2 times gives us 25? That's right. 5 times 5. There's your 2. So our answer is 5.
This is pretty cool.
Does everyone see that? Does everyone see that? That when there's nothing there, see, y'all have been taught all this time, that's a perfect square. It's always what number times itself gives you that number, right? Okay, well, it's always been times itself like 2 times. The square root of 60 is 4 times 4, right? Square root of 121 is 12 times 12. Each time's been, it's times itself 2 times because there's an understood root of 2. Does everyone get that? When you're done taking notes, put your pen or pencil down so I know. Okay, I'm going to take it to another level. Cube root. That's if you have a 3 in the check thingy, the radical. A 3, I don't know why my radical is so long, but if it's cubed, that means there's a 3 as the root. So for example, what is the cubed root of 8? What number times itself 3 times gives you 8, Gabby?
2.
That's right, it's 2. Because 2 times 2 times 2 gives us 8. So whenever you see this number, it could be a 5, it could be a 4, whatever they have here, they're looking for the root that's multiplied 3 times to get that number. Does that make sense? Does that make sense?
Yes.
Okay. All right. Nth root. Nth root is basically saying any number. Any number. On your graphing calculators, it's going to look like this. Whoops, I don't know why I put that. Forget that blob. So the nth root is any number, and I want it because I will allow y'all to use your calculators. If you have them, you would use this symbol right here to find the answer. If you don't have it, it's okay. You can use the blue calculators to play around with it. For example, what if I have 4th root of 81? So basically, what number times itself 4 times gives us 81? Taylor, raise your hand if you have the answer.
Yeah, I thought it was, but then I thought of it. I'll let Rick go.
What?
3?
Yeah.
Uh,
3 times 3 times 3 times 3 gives us 81. So the answer is 3.
Good job, Rick.
In other words, did she just say that?
Yeah.
Wait, what?
Do you want me to, what?
She said you want me to be the one to see you, not Miss Rogers.
All right, 3 to the power 4 is in fact 81.
You should go out there.
I know. All right, does everyone understand this?
See.
Are we good? All right, we're going to move on. Even root. So if we have, if the root, if the number here is even, if the number in there is even of a negative number is not a real number. It's fake.
Poser.
Poser. That's better. So if the number right here is even and the radicand is negative, it is not a real number. For example, 2 and negative 4. Not a real number. Because how can you get a negative 4?
Oh, that's
Any number multiplied by itself will never give you a negative anything. Right? Because look, negative 2 times negative 2, positive 4.
And then positive 2 times positive 2.
That's right. There's never a way to get a negative radicand if the root is even.
What if it's the other way around?
What do you mean the other way around?
Negative 2, positive 4.
We're not there yet. So what if I have 4, negative 9?
Not real.
Huh?
Not a real number.
That's right. It's not real.
It's like flowers.
You don't have to worry about it because if that's even and that's negative, then there's no way to get, it's not real. There's no number that times itself 4 times will give you a negative radicand.
What if it wasn't an even?
Okay, I'm about to do that. So if you have an even and a negative, not real. You're going to have to memorize that. Put your pencil and pens down when you're done. All right. Odd root. Of a negative number is a negative real number. Odd root of a negative number is a negative real number. So, for example, that's an odd number. So, what number times itself 5 times can get us negative 32? Taylor?
Negative 2.
Negative 2. Because if we were to do negative 2 times negative 2 times negative 2, negative 2, negative 2. If you multiplied all these together, not 2 times 5, but 2 times itself 5 times, you would get negative 32. So it is real. Let y'all catch up on writing this down. Any questions so far? All right, here's another example. Oh dear, look at the size of that radical sign.
Chunky.
Yes, you will be dealing with fractions.
Today.
Yeah. So, first of all, this is odd. Is that a real number?
Yes.
Yes.
Yeah, that's real.
Unfortunately.
It's negative, but this is odd, so there is something that times itself 3 times is going to get us this.
Actually, that's not that bad.
Anyone besides the people I've already answered? Gabby, you've answered. Aiden?
Is it negative 3 over 5?
Yep.
How on earth do you find that out? Yeah.
Okay, look,
Do it.
let me show you. 27. What times itself 3 times gives you 27? Break it up. 3. 3 times 3 is 9. 9 times 3 is 27. What times itself 3 times gives you 125?
5.
That's right.
5 just says 25. What in the world? I get it.
It's gonna be like.
It's not really that bad.
You're going to have to break it up.
It's like.
It has the Taylor seal.
It's not a guessing game. You have to know your multiplication facts.
It's like.
So, anyway, there's your answer. Any questions so far? Okay, so guess what? I have IXLs. What are you gonna do if you're freaking out right now? What do you think you need to start doing?
Study.
You're gonna have to start studying, because not only is this going to be on a test, this will be on your semester exam.
3 times 3 is 27.
No, 3 times 3 is what? 9 times 3 is. There you go. So you're going by whatever the root is. What times itself 3 times? Just like 5 times 5 is 25. 25 times 5 is 125.
So with the fractions, you're just kind of doing it twice.
Yeah, I would do the top and then you can find the bottom. Don't try to tackle this all together. Do the top first and then do the bottom one. You'd be surprised. Look, this big huge number, well not big huge, but 125 and it's 5. Even 32 and it's 2. So your tiny little numbers are typically where you want to begin to get some of this stuff. They're not going to really give you anything that's like 12 times 12 times 12 times. They're not going to do that. All right, I got to teach you a whole new thing now. Exponential and radical form. Here I taught you all the roots, and y'all are like, okay, now I'm starting to get it. Now I got to teach you a whole new thing. Typically, my students, I will tell you almost on a whole, well, after lots of practice, they'll get this just fine. They do not have problems with that. Okay? Maybe at the beginning when I'm introducing it's still kind of crazy, but eventually with the, practice and the problems we do, they start getting it. This stuff, they get confused on. So if I'm telling you that people get confused, then that's when you know, okay, I need to really focus on this. All right, exponential and radical form. This right here, that's a B, A over B. That is your exponential form. It's exponential because, look, it's got an exponent. So you got to remember, exponential form has the word exponent in there. It should look like this, a number with an exponent, right? Radical form, that's an A over B, by the way. Radical form will take this exact same stuff. See this denominator? I want everyone to look. See the denominator of that exponent? That's what goes in the checky thing. That's your radical form. See, radical because it's under the radical sign. So I want you to look at this. If I were to give you this and say, just show me the radical form of that, all you do is take the denominator, put it in the checky thing, and then you're good. That's it. That literally is it. But they get my students tend to get confused as to which is which.
So exponential is just your standard one, like the one you start
With the exponent like this in fraction form.
Do they ever ask you to do like the opposite way? Which are radical?
Yeah. They'll have this, but all you do is take this and then stick the B under the A. Whatever is the root is the denominator.
Does that mean X is the answer?
Huh?
Does that mean X is the answer if you're to work it out?
How?
How do you get?
What do you mean? X is the answer.
Because if you have, when you look at
Oh, I see what you're saying. Kind of, sort of, yeah. Or it could also be written like this. Same thing, but instead of the A being with the X, it's just on the outside of the parentheses. That's going to take some time to memorize. It's not real ugly, and I'm not going to make you do, a whole lot of work on that. So let me show you some examples. Let's say I have, I'll make it big, 8 2/3. How would I write that in radical form?
So, you write your square or your radical symbol, and then you would put the 3 in the little check thingy, and then the 8, and then the 8 squared
Yeah.
Would be the radicand.
See how you did that? Or we would do the same thing, but put the 2 out here. Y'all see that? What if I do five and 2 over 3? Michaela, how would the radical form look like?
So you would do at the parenthesis thing.
No,
Radical.
first do this one.
Put the 5 in the box thing. I don't know what it's called.
Radical.
What's that area? Yeah. And
Put
the
it-
radical.
Okay.
Yeah. And then you're gonna put the 3 in the little
Check thingy.
and then you put the 2 right there.
Okay. Or we can do the parenthesis, which is fine. There you go. Now, I'm not solving anything right now. I just want to make sure you guys understand.
Are we supposed to solve this?
I'm not going to have you do that just yet. Does everyone have any questions? All right. How about, what if I give you this, Cecilia? Bless you. This is the radical form. Cecilia, I want you to give me the exponential form.
X3 over 5.
Bingo. That's exponential. Any questions? Bless you. Any questions? Okay, so you see that none of this stuff is like ugly, ugly, ugly. It's just brand new, and you gotta remember all the stuff. See, most of Algebra 1 is building on last year. If you think about the whole year we've had, very little has been brand spanking new, you've never seen it before. So it hadn't been horrible, horrible, horrible. You know, some chapters are worse than others, but you haven't had a lot of brand new stuff. This, a lot of brand new stuff. So it's going to be kind of crazy. So we're going slow.
Got chapter 11, stuff.
Crazy stuff. All right. I have another example. Now I'm going to take it a little further. 3 and a half exponent times x and 3/4 exponent. Now, to put this, to solve this right here, to solve, in fact, I'm going to put a big old star here. To solve are y'all ready? Fractions must have common denominator. To solve, fractions must have a common denominator. So what would be a common denominator for this? That's right, 4. So, what would the new numerator be here? 2. before I move on, everyone better look at this and tell me if they understand what we did. Does everyone understand we have to have a common denominator? And does everyone understand how we got the common denominator? All right, so question. If we go back, Cecilia, the denominator, where did the denominator go when I'm putting it in radical form?
Outside the check mark thingy.
Outside the check mark thingy, right? The denominator. So look what I'm doing. Boom, there it goes. Because see, both denominators are the same now. Could we have done that if they were different? No, we'd be like, which goes in the check thingy, the 2 or the 4? So that's why you have to have common denominators. They have to both be the same so that you know what you're putting in here. So now what we're left with is 3 squared and x cubed. Cecilia, what is 3 squared? 9x cubed. There's your answer. That's how you solve those. This is in what form, Emily? Radical or exponential? That's right, exponential. Radical will always have the radical sign. Exponential has no radical sign, just a bunch of exponents. So this is your exponential form. We changed it over to a radical form. The only thing you really have to know here is you have to have a common denominator. Any questions? Let's do another. What if I have 4, 7, x cubed, y squared? That is my radical form. Michael is going to put it in exponential form. I want to see how you do.
Would it be 7 x?
Well, what about 7?
1 over 4.
Very good. Okay, notice you're going to do each term. 7 does not have an exponent, so we assume it's a 1. So it's 7 and 1 over 4, and then go ahead.
X
3 over 4.
y 2 over 4.
Hold on. We're going to do that. I know where you're going. Hold on. So all the denominators are going to be 4 because that's what's in the checky thing. So then Michael is about to move on. Look, we have to simplify any fractions. Simplify. So Michael, what would that fraction simplify to? So then my answer is going to be 1 over 4 times x to 3 over 4 and then y half. That is your answer. That is your exponential form. Any questions? Your notes better be nice and neat. Y'all got it down? All right, open up your books. Page 435. We're going to do a lot of examples. Here we go. It says, the directions say, find the indicated roots. If the root is not a real number, then state not real. All right, so number 1, the square root of 49. Now y'all see why it's called square root? Because of that 2. All right, so the square root, if, remember, there's nothing there, then we assume it's what, Michaela? 2. That's right. So what is the root or the square root of 49, Michaela?
7.
That's right. It's 7 times 7 because there's a 2 there. Remember, if there's no root, we pretend it's a 2. Very good. All right, Cecilia. 3. I have a negative square root of 36.
-6.
She is correct. -6. Again, we have no root. We're going to assume it's 2. So 6 times 6, and then she just brings over the negative sign. Or
5.
you could do -6 times -6. What?
Can I do number 5?
You're feeling daring? Okay, number 5. Shh. The square root of 49 over 16.
7/4.
7/4. Now see, don't let these fractions scare you. Do it just like I think Cecilia did in her head. Figure out the top one, then figure out the bottom one. 7 times 7 is 49. 4 times 4 is 16. Gabby? Oh, it's fine. Because we're just looking for roots. All right. Michael. Number 7. Square root of 0.01. What times itself is going to get you this? You can play around on your paper. Yes, you're going to have decimals and fractions. 0.01?
Wait, no. 0.1.
0.1, that's right. Good job. Because 0.1 times 0.1 gives you 0.01. Nine, Gabby. The square root of -196, she said, is not real. She's correct. Because this is even, and if we have an even, there's nothing times itself that will get us a negative radicand. So if it's even and negative, it's not real. Taylor, 11.
2.
It is 2. Because 2 times 2 times 2 times 2, 4 times is 16. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So can you check yourself on these? Absolutely. Absolutely you can. Before I move on, are there any questions? Everyone have this written down? I'm going to assume yes, since no one answered. All right. 13. Width. This is odd and negative. It is a real number because it's odd. So, Wick, do you know what the answer is?
Would it be -3?
That's right.
Correct.
Because -3 times -3 times -3 gives us -27. They indicated you need it 3 times, so there's 1, 2, and 3. $15, Aiden.
50?
I have, yep, 125 over 64.
The first one would be 5. Is it 6?
Well, 6 times 6 is 36. 36 times 6.
It's not that yet.
All right, so you gotta go smaller. Hey,
That's 4, right?
it's 4. 4 times 4 is 16. Then 16 times 4 is, in fact, 64. Okay, 17, I'm just going to show you. All right, Taylor, what is this answer?
142.
What?
142.
142?
1492.
Because anything squared is itself under the radical sign. Right? So anytime you're given something like this with the square under the radical sign, it's itself. That's what Taylor was trying to explain back there when we had the X underneath there. He goes, so really X is the answer of that. Yeah. Yeah, because if we were to multiply 1492 times 1492, we get this long number here, but then it would come out to be 1492 still.
Yeah.
Because it's the square root of that. Any questions? All right, 19. Emily. What do you think this is?
Isn't it using the fraction?
The fraction?
Yeah, it's like 17, 76,
And what?
the 3 must be 1.
So then what's the answer?
17, 77.
Yeah, she's right.
That's a year.
Because it's just like the one Taylor did.
Columbus sailed the ocean blue in 1492.
Exactly. You notice these are important years,
Yeah.
right? Okay. So like this, if it's squared, then that's the answer. Same thing here. Cubed, cubed, so that's the answer. Good job. All right. Let's see. 22. No, I don't like that. I'm going to skip that one. Let's go to 31. Yeah, 31.
I don't think you like 21 through 24.
I don't like those. Those are dumb.
And
Okay.
Just do it in your head.
I don't like that. To the Nick, come on. I mean, that's probably important, but I don't care. Okay. It says convert each radical to exponential form. So here we go. 3x cubed. Michaela. That's radical. I need exponential.
Okay, so you're gonna do 3 and 1/2
Very good.
And then you're gonna do x
1/2.
No, 3/2.
There you go. She got the 2, the denominator, because if we don't have anything here, we assume it's 2. That's your denominator. That's where she got the 2. The 1, because if we don't have anything, we assume it's 1. Good job. Any questions about that? All right, 33. Cecilia. 5 is a little checky thing. 3x squared, y cubed, all under the radical.
3, 1/5, x, 2/5, y, 3/5.
And she's done. What?
Have you ever started writing e and then you accidentally write a 5?
I don't know.
I do that.
All right, 35. Michael. This time we're going the other direction. They gave us the exponential. And they want you to do radical.
Okay, so you do the first check part in
Radical.
Okay, you don't really need to put anything in the checker because it already represents it.
That's right. He said you don't have to, but just for notes purposes, the denominator does go here. What goes in here?
3 and 1.
That's right. And like he said, you don't really have to leave anything in the checky thing because it's understood. Gabby, 37. I have 7 and 1/6, A and a half, and B 1/3. What's the problem here, Gabby? All right, so what would be the common denominator? 7 and 1/6, and A and what? 3/6, and then B 2/6. Now I have to reduce it. So what does this become? Oh, no, you don't. What am I saying? That is reduced. All right, so we need it in radical form. So here's my radical sign.
You're gonna put 6
Yes. Any questions? Last one. Taylor.
Yeah. 39.
3 and 3/8. R 1/4. S and 1/2. So what's the first thing I gotta do?
So first you gotta make them all greatest,
Common denominators.
yeah, the greatest, the least.
Common
Yes,
denominators.
common denominators. I was trying.
What would be my common denominator?
I was trying to say,
Okay, so if 8's my common denominator, what's my new numerator right here?
2.
What's my new
4,
numerator here?
4.
You sure about that?
Yeah.
Okay.
I was trying to say.
Okay, so now we have to put it in radical. What goes in the thing? What? And then, what do I have?
You have 3 to the power of 3, R to the power of 2, and S to the power of 4.
Now, I can't leave the 3 to the power 3. What's 3 to the power 3, Taylor? So I write 27 r squared s4. You have to simplify it. Any questions?
I'm trying to say at least common multiplier.
All right,
You said great.
now, shh. Here's the thing. Tomorrow I'm supposed to have a sub. What I'm going to do, I'm going to be here on campus in a meeting. So what I'm going to do is I have to work with 7th grade, and I have to work, because of their exam tomorrow, Thursday. So I'm going to have her come a little bit later. I'm going to get y'all started on your work. I'm going to walk around, make sure y'all have a good understanding. So when you come to class, you have your notes. You can review. You can also review tonight, right? And then tomorrow, I'm going to get y'all started. Half the class I'll be here, and then I'll just let her take it over.
What was our sub?
Miss Pappas.
Substitute